Yeah, 5126 is a pre-driver targeting base stations and 5G infrastructure. It has about 30 to 35 dB of gain, and P1 is around 25 dBm or so. It's a pretty interesting part because it is tunable across at least 4 gigahertz of range in the 3GPP standard bands. You've got the 1700 megahertz band, you've got 1.9, the 2.3 to 2.7 band, the 3.3 to 4.2 band, and even 4.4 to 5 gigs. So it's a pretty versatile part that can be tuned across quite a wide range of bandwidths and bands. I'm actually trying to extend it a little further up to 6 gigahertz to see how much we can get at that frequency. But I mean, obviously the part itself is, there's nothing I can do internally. There's some circuitry around the input match, the output match, and then there's an interstage feed inductor that can be used as matching as well. So it's really just a combination of finding a good return loss for the particular bands that you're interested in, and that can be done by adjusting input and output match. We've kind of just targeted down to 1.8, and really what sets it is what are the target requirements. Lower than that, it is a PHEMT device, so it can certainly have gain all the way down to 100 megahertz or so, but depending on your output power requirements and linearity, that can certainly be constrained by what's internal to the part. There might be some shunt capacitance in there that's limiting you to a certain bandwidth, or just size of different component values. But to be honest, I haven't really looked much below 1.8 just because there wasn't a requirement. But it's certainly something we could look into. Certainly parts, we have a target requirement that we design for, and certain use cases come up to where maybe it's slightly outside of that requirement, and our applications team will take a look at what the performance could be outside of that range, and sometimes it's feasible, sometimes it's not, but a lot of times we surprise ourselves with some interesting tunes and make it work in places where we didn't know it could work. I think there was a request to have that mode several years ago to operate with basically 2 different customer base station requirements. So we were trying to target one part that could hit multiple customers without having to have 2 separate parts. And one customer needed a higher gain, and the other customer wanted something 5 or 6 dB lower. But I think today I haven't really seen a need for the lower gain mode that we currently offer. if anything, customers are looking for more gain than we currently have. So, but we'll see. It offers an option that maybe the customer doesn't want to handle having to put additional circuitry in their system, and that particular lower gain is exactly what they need. So we have that in our as a feature in the part, toggle between the two gain modes, and it's pretty seamless. It's easy to use. It's just a V gain digital pin that if you want to just keep it in low gain mode, you can ground the pin. If you want to keep it in high gain mode, you can tie it to a VDD or a 5. Only needs 1.8 volts, but you could tie it to a 5-volt rail if it's more convenient. Yeah, some of the challenges that we've had with this part, I'd say the main one is that it's not inherently a high linearity device like our power amplifiers. We try to have something that has a lot of linear power. This particular driver, in order to get that linear power, would require some kind of digital pre-distortion, which a lot of our infrastructure systems use, so it's not a problem, but it's just something that if customer wanted to use it as a linear driver, they might run into issues getting enough linearity. But it does put out a lot of power for pretty low current. That is a nice feature to have. Another challenge we had was that customers like to see very fast turn on and turn off times. This part does extremely well now, but we had some challenges trying to figure out why it would cause some EVM issues if you did not allow for enough time for the part to settle. And that's something that we've taken a look at more closely, and we've had to set up special system arbitrary waveform generator and things to help pulse the part to emulate what might happen in the system. Yeah, the pulse EVM is a challenge. I think a lot of our competitors have as well. It's just the dynamics of 5G and TDD systems. If customer wanted to operate the part and fully optimize the efficiency where they would turn the device completely on and off, that requires very fast settling time, which this part can perform. And I think it takes under a microsecond for rise and fall time, but there are some considerations that need to be made with the circuitry just to not have too much bypassing on the line, and we can certainly help the customer in their application, making sure that they can optimize for that timing scenario. So one other thing that might be advantageous to the 5126 would be noise figure. Since it does use our PHEMT technology, we're able to achieve lower noise figure than, say, an HBT process or some other technology. And if customers looking for a lower noise figure part, the 5126 can certainly offer an advantage there. It's not necessarily an LNA, but it does exhibit some of the same low noise characteristics of an LNA.
Thank you so much for watching. If you'd like more information, please email us at sales@guerrilla-rf.com. And don't forget to subscribe to our channel for more content from Guerrilla RF.